So there are multiple issues within this network. PC1 is unable to ping PC2, and I'm just going to verify that. So and as you can see, PC1 is unable to ping PC2 as we just got destination host unreachable. I'm going to now look at router 2 to verify router 2's configuration is correct. Those network statements are correct, so the LAN interface has been made a passive interface, that's fine. Neighbor. So there is no neighbor relationship established between router 2 and router 4. F20. The hello interval and dead interval on router 2's fast Ethernet 2.0 interface is the default values, which is great. So OSPF uses a default hello interval of 10 and a default dead interval of 40. Show IP OSPF interface brief, and OSPF has been enabled on both the fast Ethernet 3.0 and fast Ethernet 2.0 interfaces on router 2. They both have a process ID of 1 and they're both in area 1. You don't need to use the same process ID on both routers to establish a neighbor relationship. So for example, if I use process ID 1 I enable OSPF with process ID 1 on the fast Ethernet 2.0 interface on router 2, and say for example I enable OSPF on router 4's fast Ethernet 2.0 interface as a process ID of 2, that's okay. The neighbor relationship will still establish because you don't need to use the same process ID in OSPF. Process IDs are locally significant only, so I'm just going to check router 4 now. So an issue on router 4 is OSPF has been enabled on the fast Ethernet 2.0 interface of router 4 in the wrong area. For OSPF neighbors to form a relationship, a successful relationship, then both the interfaces connected to the other router. So for example, the fast Ethernet 2.0 interface on router 4 and the fast Ethernet 2.0 interface on router 2, they need to be enabled in the same area. If they're in different areas, then a neighbor adjacency in OSPF will not form. Because this has been enabled, OSPF has been enabled on the fast Ethernet 2.0 interface on router 4 in the wrong area, that will cause the routers to not form a neighbor relationship. Also, another issue is that the fast Ethernet 2.0 interface on router 4 has been made passive. If you make a interface connected to another router as a passive interface, they won't perform a successful neighbor relationship, because if you enable the interface as a passive interface, it won't send out hellos, and for OSPF routers to form a neighbor relationship, they must send hellos and receive hellos successfully. So I'm going to fix these issues. Conf-T for configure terminal, router OSPF 1, because that was the process ID used. As you can see here, and I'm going to go no network 192.168.1.0, mask was 0.0.0.3 for a /30 subnet mask, and the area is 0. Now I'm going to configure this network in area 1. So this interface of fast Ethernet 2.0 and router 4 will be enabled in area 1. And I'm going to make it not a passive interface, because as you can see here, the fast Ethernet 2.0 interface was made passive. And now we're going to verify this is all working. So now we have the fast Ethernet 2.0 interface in area 1, as you can see here. And now there's no passive interface, so fast Ethernet 2.0 is not a passive interface now, so now router 4 will be able to send hellos and receive hellos. OSPF neighbor, and as you can see here, router 4 has now established a successful neighbor relationship with router 2. The neighbor ID being 192.168.3.1, which is the router ID of router 2. Just to verify that, we can go here and verify. There are multiple ways to verify the router ID. As you can see here, the router ID 192.168.3.1. You can do show IP protocols. You can go show IP OSPF, and this will also tell you the router ID, and you can also verify by this command as well. So the designated router ID is 192.168.3.1, which is this router here, router 2, and the backup designated router is router 4 at 192 excuse me, .168.1.1. OSPF neighbor, and that verifies that we have a neighbor relationship with router 4 at 192.168.1.1, which is router 4's router ID. And this tells us that the state of the router 4 is a BDR, and the full state means, as I said, for OSPF neighbors to form a relationship, it has to reach a full state. If the routers are DR others, they will stay in a two-way state permanently. But if what happens is OSPF will form an election based per segment. So per segment meaning this is one segment, this is another segment, this is another segment, this is another segment. So there's an election on each segment. So there will be a DR and a BDR per segment. And this is done based on the highest RID or the highest priority. And as for the router ID, RID being router ID, the router ID is if you manually configure the router ID via the router configuration mode, then the manually configured router ID, that's what the router ID will be. If you haven't configured a router ID manually, then the router ID will be the highest loopback address, because we don't have any loopbacks configured in this network. The router won't use a loopback address for the router ID. If you haven't manually configured a router ID and you haven't configured any loopback addresses, then the router will use the highest configured IP address, which in this case router 4 has used the highest IP address as its router ID, because 192.168.1.1 is higher than 182.14.1.2. It has used this IP address because it's the highest IP address configured on router 4. And router 3 has used the 192.168.3.1 IP address as its router ID, because that's higher than 192.168.1.2, and we haven't configured any router IDs manually on router 2 or router 4. I'm going to check the IP routing table on router 2, and we have a OSPF inter-area entry for the 182.14.1.0 network. So router 4 is successfully advertising that network to router 2, so I should be able to ping the 182.14.1.1 IP address, and no, looks like I can't. Do a trace route. Trace route's used so you can see where the packets are dropping in the network, so that will help you find out exactly where on the network you need to be troubleshooting to fix the problem. So I'm doing a trace route to that address, and it looks like the packets aren't getting through past router 4. So if I go Control Shift 6, that will get rid of that and stop the trace route, otherwise that will take forever. Go to router 4 now. OSPF has been enabled on the fast Ethernet 00 interface via the interface command to enable OSPF, and that looks correct. IP OSPF neighbor, and there's no neighbor relationship between router 4 and router 1. Show the OSPF interface brief, and fast Ethernet 00 has been enabled in the correct area of area 0, so that's correct. Show IP OSPF interface fast Ethernet 00, and as you can see here, the hello interval and dead interval for the fast Ethernet 00 interface of router 4 are not the default values, so I'm going to check router 1 and compare the hello and dead intervals to see, because the hello and dead intervals on both routers need to be the same to form a successful neighbor relationship. That is an issue. Router 1 is using the default hello and dead intervals. The default hello interval in OSPF is 10 and the default dead interval in OSPF is 40. So as I said, these hello and dead intervals need to be the same. So I'm going to change the hello and dead intervals on router 4. So conft interface F00, and I'm going to go no OSPF hello interval 15 and no OSPF dead interval 50. And just to verify that router 4 is using the default timers. Using the default hello interval of 10 and the default dead interval of 40 on the fast Ethernet 00 interface. Just going to verify that there's no other problems. So that's correct. That's correct. And the IP addresses are configured correctly on both R1's interfaces. As you can see, fast Ethernet 00 182.14.1.1 and fast Ethernet 20 182.14.2.1 has been configured in those interfaces. They're both in an up state. A relationship established with router 4, because router 4 is using the router ID of 192.168.1.1. It's in a full state, and router 4 is the designated router on this segment. Next hop address being 182.14.1.2, which is this interface in router 4, and the outgoing interface is fast Ethernet 00 of router 1. The default priority on OSPF is 1, so it's using the default priority value. Now we're going to check between router 1 and router 5, see if there's any issues there. in area 0, that looks correct. 192.168.1.1 168.2.0.0.0.0.3, which is enabled. It is enabled for the /30 subnet in area 2. So that looks correct. Router ID. So the router ID has been manually configured on router 5. Router ID 1.1.1.1. So that's configured manually on router 5. Just going to go to router 1. Established with router 1. It's in the full state, and router 1 is the designated router on this segment. And we do have a neighbor relationship to R5 at 1.1.1.1, R5 being the backup designated router on this segment. Now let's check router 3. OSPF has been enabled on the fast Ethernet 3.0 and the fast Ethernet 0.0 interfaces of router 3, and they are in area 2, which is correct because both these interfaces are in area 2. So fast Ethernet 0.0 has been enabled via the interface OSPF command, so it's been enabled directly on the interface, and it hasn't been enabled via a network statement in router configuration mode. Passive interface, so fast Ethernet 0.0 is a passive interface, which is correct because you want your LAN interfaces to be passive interfaces, so the router doesn't send routing updates out those interfaces, because you should only need links connected to, or interfaces connected to other routers to be not passive interfaces, because you need to send and receive updates on interfaces that are connected to other routers, but you don't need to send and receive updates on interfaces that aren't connected to another router. That's just wasting resources and using up more router resources than you need to. So it's a good idea and best practice to make interfaces that aren't connected to other routers passive interfaces, whether it be OSPF, EIGRP, So an issue we have between router 5 and router 3 is they're using the same router ID. You can't use the same router ID in OSPF. If you use the same router ID between two routers that are connected to each other, then they're not going to establish a neighbor relationship. As you can see here, because router 5 and router 3 are using the same router ID, they're not going to form a neighbor relationship. As we can see here, no neighbor relationship. Show IP OSPF neighbor R5 has is with router 1. So we need to change the router IDs. So I'm going to change the router ID on router 3. So configure terminal router OSPF1, because we use the process ID of 1. And we do no router ID 1.1.1.1. And I'm going to have to clear the OSPF process. Just be very careful doing this on a live network, because when you clear the OSPF process, OSPF on the network's not going to work properly because you're clearing the whole process, so it can cause issues and downtime on the network. Reset the OSPF process, but because in a lab environment like here we can clear the OSPF process, no worries. So we go show protocols again, and now router 3 is using the router ID of 192.168.4.1, which is the highest IP address that router 3 is using, because that's a higher IP than 192.168.2.1. 2, because that's the other IP address that it's using. Let's see if there is a neighbor relationship established now between router 3 and router 5, and there still is no neighbor relationship between router 3 and router 5. Okay. So let's check the interfaces on router 5 and router 3. So if I go show IP interface brief, show IP interface brief. So fast Ethernet 3.0 is using 192.168.2.2 is in an up state, and fast Ethernet 3.0 is using 192.168.2.5 is in a up state. So because this is a /30 network, for routers to form a neighbor relationship, they both need to be on the same subnet, because 192.168.2.5 is in a different subnet than 192.168.2.2. The routers won't form a neighbor relationship, so router 3 and router 5 won't form a neighbor relationship. They have to be on the same subnet. For OSPF v2, they must be on the same subnet. For OSPF v3, which is OSPF for IPv6, they don't need to be on the same subnet. So for IPv6 OSPF, which is OSPF v3 as stated, you can use a different IP address on both interfaces connected to the routers, and they will still form a neighbor a neighbor relationship, because they use the link local addresses. But we're doing OSPF v2 today. So we've got 192.168.2.0/30. Okay, the first block 0, 4, because we're going up in 4s, so the subnet mask could be 255.255.255.252 in a /30, and it's out of 256, so we're using 4 addresses, one for the network and one for the broadcast address. So the blocks would be like so. The network address meaning 192.168.2.0 and the broadcast being 192.168.2.3. So the only usable addresses we have here is 192.168.1 and 192.168.2.1. 192.168.2.2. And as you can see here, this address on router 5 for fast Ethernet 3.0 has been set to 192.168.2.5, and for router 3 it's using 192.168.2.2. so as you can see, router 3 is in this subnet and router 5 is in this subnet, because the usable addresses is 5 and 6. So we need to put router 5's fast Ethernet 3.0 interface into this subnet, so it's on the same subnet as router 3. So I'm going to do that now. T return interface F30, IP address 192.168.2.1, and /30. Shut down. And now it is using the 192.168.2.1 address. Another way to verify, so the interface brief, and as you can see, fast Ethernet 3.0 192.168.2.1, and is in a up state. So it is now in the same subnet as router 3 now. So we're going to verify if router 5 and router 3 have now established a OSPF neighbor relationship. So show IP OSPF neighbor, and as we can see here that router 5 has formed a neighbor relationship with router 3. So because that is the router ID of router 3, 192.168.4.1, and router 3 is the designated router on this segment. And we're going to see if router 3 has OSPF routes in its routing table, and it does. So it has an entry for 182.14.2.0, 182.14.1.0, 192.168.1.0, and the 192.168.3.0 network, which is down here. They are inter-area routes, which means that these routes were learnt from a different area. When you see a route with just O without the IA code, that means it is an intra-area route, and an intra-area route means that the route was learnt within the same area. So if we go to the backbone area 0, go to router 1 for example, show IP OSPF, no, we'll go to router 4, and because router 4 is a ABR, it is learning routes from the same area and from other areas. So this O meaning this is an intra-area route, so it was learnt in the same area, area 0. So this was learnt from router 1. So router 1 has advertised this network to router 4, and because this is in the same area of area 0, it has been learnt in the same area, so an intra-area route. This route has been learnt from this area, area 2. So that is an inter-area route, because this network has been learnt from area 2. Now we're going to see if PC1 can ping PC2. So ping 192.168.4.10, and as you can see here, PC1 can now ping PC2 at 192.168.4.10. Now we're going to see if PC2 can ping PC1. 192.168.4.3.10, and as you can see, PC2 can now ping PC1 at 192.168.3.10. Hope you found this useful. Thank you for watching, and I will be making more videos. Please like and subscribe if you want more videos. Thank you very much.